Hey everybody, today's lesson is all about linear inequalities. So this is going to be really similar to stuff that you've done since really junior high school. Hopefully it's going to be easy. Graphing linear inequalities is very similar to graphing equations. The big difference is we need to do some shading. Now there are three main steps to graphing inequalities. First, you want to isolate y as on the left hand side if need be. Okay, so that means getting it into gradient to intercept form. Why we really want to make sure we have it in this form is because that's going to help us with our shading. Then we want to graph the line as usual, but make it a solid line for any time you have these inequalities that include the equal to sign. So that's less than or equal to or greater than or equal to. You're going to have a solid line, and then you're going to have yourselves a dashed line for any time that you see y is strictly less than or strictly greater than. You want to shade above the line for any greater than symbols and below the line for any less than symbols. We'll try and make it as simple as possible. You guys remember what to do. Let's go through a couple of examples. Okay. First, graph the inequality y is less than x over 2 plus 3. So step 1, hey, it's done. It's already isolated. Woohoo. So let's go ahead and graph it. Remember how to graph these. We have x over 2 means that your gradient is actually 1 over 2. And then c, your y-intercept, is a positive 3. So I know my line's going to be going up and to the right, and I will go ahead and make sure that I go up at least to positive 3, because hey, there's my y-intercept. I'll go ahead and go a few more, try and keep the same scale as much as possible. Okay, and now with my slope, I'm going to go up 1 and to the right 2. So up 1, right 2 is going to be at that point there. It looks like that's 2, 4. And then I can also go down 1 and left 2. And that would be over here at negative 2, negative 2. And then just go ahead and connect your dots with a straight line. That's not very straight. Let's try it again. That's pretty good. And now we do the shading. So we did step 1, or step 1 was already done, so this is like really your step 2, and now we have our step 3. We want to shade. So shading, it's a solid line because we had that less than or equal to, and since it is less than or equal to, we are going to end up shading everything below the line. And that shows that we have our solutions are anything in that shaded region. That's what inequalities are telling us. It doesn't have to just lie on the line. It's on the line or anything below the line too. So inequalities are really interesting for that respect. Okay, now let's go ahead and do the next example. Next example, we have two different equations. We've got one that's y is less than and 3x minus 2y is greater than. What does that tell us? Let's go back up to the top of our notes. If you are asked to graph two linear inequalities, aka a system of linear inequalities, then the solution is the double shaded region. So let's just take them one at a time. That's basically all we really need to do. So let's take them one at a time. First one's going to be super easy, right? Y is less than 3 over 4x minus 3. It's already done. We'll go ahead and call this equation number 1. Okay, it's already in the y is less than all by itself, so it's in point gradient form. We have our slope is equal to 3 over 4, and our y-intercept is negative 3. So I can go ahead and graph that line. And I know I'm going to go down 1, 2, 3. Down here is going to be my y-intercept, and I know I need to go at least over to the over 4, because my slope is up 3 over 4. This one is a dotted line that we are going to use, okay? Because we are looking at strictly, this is going to be a dotted line, which means my solution doesn't actually land on that line. It's going to either be entirely above or below it. So this is our graph for equation number 1, or inequality number 1. And we want to make sure that we end up graphing below the line, okay? We know it's below the line because it's less than. So below the line is going to be all of this stuff here. Okay, so that's number 1 done. Let's go ahead and do number 2. Number 2, we have 3x minus 2y is greater than or equal to y. So with this, we have a little bit more work we need to do. Still, we have 3x minus 2y is greater than or equal to 1. Y is not by itself, so let's get it by itself. Now, inequalities, if you remember, are kind of tricky when you've got a negative sign. Okay, if you ever have to multiply or divide by a negative sign, you have to make sure that you flip the inequality sign. Now, I never really understood why that was, and honestly I would frequently forget about it. So let's show you a different way to do it. Instead of moving the 3x over to the right hand side, let's go ahead and add 2y to the right hand side. And then we'll subtract the 1 from both sides as well. And that's going to give me now 3x minus 1 is going to be greater than or equal to 2y. Okay? Now let's go ahead and divide both sides by 2, and we have 3 over 2x minus 1 over 2 is going to be greater than or equal to y. And so now y is all by itself. The only issue is that we have the y on the right hand side compared to the left hand side, and we generally with inequalities we want to have the y on the left hand side. So I'm going to put the y on the left hand side, but I'm not doing it by addition or subtraction. Now this is where the flipping of the sign comes in. Notice the direction that this is pointing. It's pointing to where the pointy part is toward the y. Have the pointy part towards the y. Notice how the inequality sign flipped. Okay, that's why we end up flipping. If you're multiplying or dividing by negative, essentially what you're doing is you're moving it to the other side of the inequality sign, the same way you would do if you were adding or subtracting. Okay, so it's changing its position relative to that inequality sign. That's why the inequality sign flips. Okay, so we have the rest of it. Nothing else changes. We have 3 over 2x minus 1 over 2. Now this is an easy one to graph. Let's go ahead and graph this one. Let's see, negative 1/2 is my y-intercept, and my slope is a positive 3 over 2, so I need to go up 1, 2, 3, 4, 5. We'll just go have this way, and we'll go to the left just for kicks. I'll make sure to have my scale showing that each tick mark is worth 1. We're going to go up 3 and over 2, so 1, 2, 3 over 2 is going to be right here. It looks like 2.5 comma 2. Okay. And then we're going to do the same thing. I'm going to now go down 2 and left 3. Okay, down 2, or down, down 3, left 2. 1, 2, 3, and left 2. And now what we want to do is draw these connecting with a straight line. Okay, now one thing that I'm going to need to fix here is that I didn't extend out my other one quite enough. So I'm going to extend that out and continue my yellow, shading everything that was underneath there. Now we got to do some double shading. Let's go ahead and shade in blue everything that is below this other one. So now everything that we want is going to be that double shaded region. So what we can see is that we are bound by this part that I'm going to make in red. And then what you want to do, since I have to erase everything and reshade, but this is why you use a pencil, right? Erase everything that has not been double shaded. So those are my boundaries, okay? And I want to erase everything else but keep what's below that double shaded part. And this is going to be the shaded part of my solution. It's always best, if you can, to shade in the part that is your solution and solution only. Don't rely on the reader to see double shading. Okay? That's it. You are donezo. Go ahead and try the next you do, and I will see you guys in class for some more practice. Have a great day.